As we start topic 1 of chapter 3, I'm going to ask you to go ahead in your booklet until you get to this page. I had originally thought we would set this up in the form of a quiz, but I think we'll just give it as a sort of rhetorical quiz, and watching and writing hopefully will help in having this through repetition be a good background for many of the formulas that we run into in chapter 3. So this first formula here, some of you may know the name. This is a linear equation in two variables in what we call standard form. So the linear equation in two variables, when it's like this is referred to as standard form. Now, here we see the letter y. If we solve what's there for the letter y, it ends up looking like this, where the letter m refers to the slope. That's the letter m. And the letter b refers to the y-intercept. Now, when you have an equation in standard form and you solve it for y, so y is a positive y equals something, in this form, this is called the slope-intercept form. Of the linear equation in two variables. All right, let's raise it up. Now, here we see the letter m. This is the slope. And letter d refers to this. This is an ordered pair. And in an ordered pair, the order is important. X comes first, followed by the y. Now, if we have two sets of ordered pairs, we could put them in this formula. And when it's in this arrangement, this is the slope formula. Going on to number 4, this is a special arrangement where you have one point, one ordered pair, you have the slope, and again we're saying the m here is the slope. And this formula in this form is called the point slope form of the linear equation in two variables. All right, let's go on. Now, items 5 and 6, here we have y equals b, and an example, y equals 3. Well, sometimes the ordered pair can be listed as a, comma, b, which is, in a sense, x, comma, y. So the x would be the a, and the y would be the b. So here we're saying y equals b. Well, this is a special kind of equation. When it's in this form, this is an equation of a horizontal line. Now, what does that mean? Well, in an ordered pair, whatever is in the B position, which is in this case the 3, y is 3, makes it a horizontal line going through the y coordinate at 3. Now, an additional item we'd like you to mention here is the slope of all horizontal lines is 0. So again, we're introducing a lot of things we'll be covering in Chapter 3. Here we're sort of summarizing, exposing you to it, and then hopefully from time to time you'll study this sheet, going from review into hopefully long-term memory. All right, number 6, special equation as we deal with graphing. X equals A. Well, in our ordered pair, the A refers to the X item, such as X equals a negative 2. Well, this is a special equation of a vertical line. So we put a dot then on our X coordinate, negative 2, and then we're going to put a line through it. So again, introducing you to formulas used in Chapter 3. Now, as a little extra, what is the slope of all vertical lines? And the answer is, it's undefined. And the reason for that is if you use the slope formula above, you end up with something like 3 over 0. So anything divided by 0 is undefined, where in number 5 you would end up with 0 in the numerator divided by 3. 0 divided by any number other than 0 is 0. All right, let's go to our second column. Now, for number 7, this isn't exactly a formula, but more or less a rule, that if your slope of one equation equals the slope of another equation, but the y-intercepts, the b's, do not equal each other, we say the lines are parallel. And this is the symbol for parallel. And here you can just write that up. I'll shorten it, slopes. So something like that. Slopes are the same, but the y-intercepts are different. Then lines are parallel. Shortened it a little bit. Now for number 8, again, a general rule. Here we're going to multiply the slope of one equation by the slope of the other equation. If it equals 1, a negative 1, such as 1/2 times a negative 2 over 1. It's the reciprocal of 1/2, but the opposite sign. The results are a negative 1. Then the lines are perpendicular. That is, when you would graph them, they would end up forming a right angle here. So let's summarize that. So something like this. Now, the inverted capital T is the symbol for being perpendicular. And then if the product of the slopes are a negative 1, when you multiply the slopes together, you get a negative 1 as a result, then the lines are perpendicular. Example would be 1/2 times the negative 2 over 1. It's the opposite negative, or the opposite sign reciprocal of one slope compared to another. Another example would be if you had a negative 3, then you would multiply that by a 1/3. In a sense, that's a negative 3 over 1. Opposite signs gives you a negative 1. All right, let's go on. Number 9 now goes through another general rule, background. If you have an equation in standard form, which is this one, we illustrated that as number 1, and here would be an example. You can make a special T-chart. Now initially it looks like a T. You put an X there, a Y there, a 0 there, and then next line down a 0. Now, I call this special T-chart an X and Y intercept T-chart. I gave it that special name. And I'd like you to remember that because I may ask that as a quiz question sometime. Now, if you put a 0 as a value for X here, 3 times 0 is 0, you get 4y equals 12. If you solve for y, divide both sides by 4, y here is going to be 3. Now, if y is a 0, this y is a 0, 4 times y is 0, you now get 3x equals 12. Divide both sides by 3, you get x is a 4. Now, if you plot these on this graph, 0, 3, so 0, 3, 1, 2, 3, you put a dot right there, and you go 4, 0, 1, 2, 3, 4, 0, and then you put a line through that, then you'll note that right here, and right here, the line crosses, in this case, the y-axis, and over here, the x-axis. These are referred to as the y-intercept, where the line crosses the y-axis. Where the line crosses the x-axis, the x-intercept. Now, these also have a formal way of being described. The y-intercept is referred to as 0, b, and the x-intercept is a, 0. So when you are asked to plot using the intercepts, if the equation is in standard form, it works out very well. You make an x and y intercept T-chart, fill it in, find your values, and this is what the Hawks software will ask you to put in. Write the y-intercept, write the x-intercept, the graph forms, and you have plotted the graph by plotting the intercepts. This would be a way to do it on paper. Now, for our last hint, and again, we'll be reviewing this as we go through the chapter, plotting using the slope-intercept form. Now, you may recall the slope-intercept form was y equals mx plus b. This was equation 2 on the other side. Well, if the equation is in this form, this gives us an easy way to graph. Because if we know, for instance, as we have in this equation, y equals 1/3 x minus 2, we know the y-intercept. So the y-intercept, we put a dot on the y-intercept, which is right here, negative 2. Now we also know our slope. Now from that point, we're going to plot the slope. And slope is a ratio of rise units, which are y, overrun units, which is x. And when we plot this, if it's positive, and there's different ways to do this, but I would suggest you do the run first. Run is horizontal. So it says 3 x units. So we're going to go over 3 mentally. 1, 2, 3. And now we're going to go up from this point 1 unit. And then that is the line that we graph. I'm just going to sketch this here. I don't know how, okay, I'm pretty good here. And there's the graph. Now, in the Hawks software, what you would have to do is you would put in there, let's say, this point here, which is your y-intercept as 0, -2. And then you'd have to put in this other point here, which is going to be 1, 2, 3, and then down 1, -1. Again, if you're doing it on paper, or if you have to put it into the software, there are different ways. And we'll call that then our review. And we'll end this and start the actual classwork lessons in a few moments.